In this section, we're going to study parabolas. Let's give a definition. A parabola is defined as the collection of all points P in the plane that are the same distance from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola, and the line D is its directrix. As a result, a parabola is the set of all points for which the distance from the focus to any point on the graph of the parabola is equal to the distance from any point on the graph of the parabola to the directrix. To help you visualize the idea of a parabola, we have here a graph. So the point F is labeled as the focus. The distance from that point F to some point on the graph of the parabola is labeled as the distance from F to P. The distance then from F to P is equivalent to the distance from the point on the parabola to the line labeled the directrix. From this definition, we can get equations of a parabola. In particular, if we have a parabola that opens to the right, we have the equation is given as y squared equals 4ax. The vertex of the parabola is located at the origin. The focus is located at the point A, 0. The equation of the directrix is x equals -8. Let's look at an example. In this first example, we're asked to find the equation of a parabola whose vertex is 0, 0, the origin, and whose focus is 3, 0. What we should notice is that the vertex is at the origin and the focus is on the positive x-axis. That would mean that my parabola needs to open to the right. Because my parabola is opening to the right, the equation of the parabola is going to be of the form y squared equals 4ax, where a is the distance from the vertex to the focus. The distance from the vertex to the focus is 3 units, so a is 3. We then get the equation of the parabola is y squared equals 4 times 3 times x, or y squared equals 12x. Let's go ahead and graph this parabola. We graph the parabola by recognizing that the vertex is at the origin, the focus is on the positive x-axis at the point 3, 0. We then will graph the directrix at the line x equals -3. So the directrix is over here at x equals -3. Now what we need to do is find a couple of points that lie on the graph of the parabola in order to determine its opening. These points are going to be found by letting the value of x equal 3 in the equation. In other words, we know that y squared equals 12x. Let x equal 3 in the equation, we get y squared equals 12 times 3, or 36, which means that y equals plus or minus 6. That means we have 2 points on the graph of the parabola, 3, -6, and 3, +6. These points are referred to as the latus rectum. So we're going to label the point 3, -6, and 3, +6. These points are going to help us determine the size of the opening of the parabola. We draw our graph through these 2 points, and we obtain the graph of the parabola.